So in this lecture, I'm going to be explaining sBert, which is sentence embeddings using Siamese Bert-networks. The thing about Bert or Roberta and those pre-trained networks, when you want to use these pre-trained networks, people are not aware that it suffers from many problems. One of them is anisotropy. So all of your points are in a very limited space, in this big high-dimensional space. So one of the ways that we can avoid this problem is through contrastive learning. And so this paper is focused on using sBert for sentence representation, but it uses Siamese network. And these are positive samples. They are related to this idea. And Bert and Roberta has set a new state-of-the-art performance on sentence-Bert regression tasks like semantic textual similarity. However, it requires that both sentences are fed into a network, which causes a massive computational overhead. And finding the most similar pair in a collection of 10,000 sentences requires about 50 million inference computations, which is about 65 hours with Bert. And the construction of Bert makes it unsuitable for semantic similarity search, as well as for unsupervised tasks such as clustering. So they present sBert, which is a modification of so they present sBert, which is a modification of this pre-trained Bert network. It uses Siamese and triplet network structures to derive semantically meaningful sentence embeddings that can be compared using cosine similarity. And this reduces the effort for finding the most similar pair from 65 hours to just 5 seconds with sBert. And in this context, they have used it for NLI dataset, which is, so they look at it as a kind of supervised learning. But in general, in contrastive learning, we usually talk about unsupervised learning. But here in this paper, they focus on supervised approach for their problem, which is NLI, natural language inference dataset, NLI dataset. Of course, people may argue that this dataset is very simple, but so they use this in this article. So it's a bad practice that we average Bert output layers for sentence embedding. So we can avoid this problem by using this approach. To alleviate this issue, we develop sBert. The Siamese network architecture enables that fixed size vectors for input sentences can be derived. Using a similarity measure like cosine similarity or Manhattan distance or Euclidean distance, semantically similar sentences can be found. And these similarity measures can be performed extremely efficient on modern hardware. So it allows sBert to be used for semantic similarity search as well as for clustering. There are three pooling strategies you could use: either output of CLS token, or the mean of all output vectors, or just computing the max over time. We call it max strategy. And so we give the sentences to identical Bert, and then we do pooling. Your pooling could be, as I said, could be mean pooling, max pooling, or just take the last token. So finally, we have two vectors, and two vectors, you can concatenate them. You can also concatenate the difference between them. You can also concatenate the dot product between them, and so on. After that, you can do a softmax and do a classifier, or you can also do regression, so something between 0 and 1. So the classification objective is just concatenate these vectors and then give it to a linear network, and finally the softmax, so it gives you the output. Or for regression, as I said, you could use regression instead of classification. And the triplet objective function can also be used, because you have an anchor, you have positive and negative. So we want to avoid this, so to make it larger and larger, and to make this shorter and shorter, because this is a positive and this is negative with respect to your anchor point. So they train the S-Bert on the combination of SNLI and the multi-genre NLI dataset. And the SNLI is a collection of 500,000 sentence pairs. And so we have two sentences, sentence 1 and sentence 2, they either entail each other. So it's either entailment, it means it causes something, or it either contradicts that one, or it is neutral, none of the above. So it's just a three-way softmax classification.